Start?
Yep.
Okay. All right, welcome everybody. My name is Doug Chuang, and this is Jude Cross. We are both cloud engineers at Blizzard Entertainment in the cloud system team. And we are here today to talk to you about autoscaling Overwatch. Now, when I mention autoscaling, what first comes to mind for most people is the AWS autoscaling. Oops, sorry. And in fact, AWS was the first one to widely popularize autoscaling when they introduced it in 2009 for the EC2 instances. Now, on the OpenStack side, you had autoscaling with Heat since the Havana release. But really, there's another way to do autoscaling, and that is using Senlin. Now, at this point, you may be wondering yourself, what is Senlin? And I had the same question actually 18 months ago when I first joined Blizzard. In fact, it was on my very first day at Blizzard Entertainment that I had a meeting with my new boss, and he was telling me that we wanted to use Senlin to do autoscaling. Now, I've worked with OpenStack prior to that day, but I've never heard of Senlin until that day. And not only did he want me to integrate Senlin into our private cloud, he also wanted me to implement lifecycle hooks in Senlin for reasons that will become apparent later in this presentation. Now, given that was my first day on the job, of course, I told him there will be no problem. And I went back to my desk and tried to figure out how to spell Senlin and find it in Google. But eventually, I was able to figure out that Senlin was a clustering service in OpenStack that allows you to do scaling, and it has been around since the Mitaka release. Now, before I go into the details of autoscaling, let me take a moment to introduce Blizzard Entertainment to you. Blizzard Entertainment is a video game developer, and we have been around since 1991. We are located in Irvine, California, and of course, our most popular title is World of Warcraft. But we also make other games like Overwatch, StarCraft, Diablo, Hearthstone, and Heroes of the Storm. And today, we'll be specifically talking about Overwatch. Overwatch, for those of you who don't know, is a team-based first-person shooter. And it has a global, worldwide player base. And they launched in 2016. And since launch, they've been running in our private OpenStack cloud. And since the beginning of this year, we introduced autoscaling for the Overwatch game servers. Now, OpenStack has had a long history at Blizzard. We've been using OpenStack since 2012, and we are running it across 11 data centers worldwide. And our users of the OpenStack cloud are our internal game development teams and internal application developers. All our OpenStack services are mostly running Rocky release, with a few exceptions still in Pike. And the other exception is that Senlin is running on the most recent Stein release. In addition to being an OpenStack operator, we are also actively contributing to Senlin, Magnum, and Designate project. And in fact, I was the PTL for the Senlin Stein cycle, and we're both active co-reviewers in Senlin. And we also contributed to Gopher Cloud and enabled Senlin and Zakar support. So why do we need autoscaling? Well, autoscaling in the public cloud the benefits are very obvious. You use less instances and your costs are reduced. But in a private cloud like Blizzard, you can imagine we have a finite capacity. And without autoscaling, that capacity gets divided up by different games. And then we have some amount of spare capacity left. What happens is that each game will allocate a set number of VMs that will be able to handle the peak traffic for that game during any time of the lifetime of that game. And that includes new content releases or seasonal events. But really, what happens during non-peak times is that the load is spread among those VMs, and each VM is essentially underutilized for the size of CPUs and RAM. With autoscaling enabled, what happens is that that load will get packed more tightly into the existing VMs during non-peak times, and other VMs are not being used anymore, and that becomes free capacity, which can then get redistributed to other games. So when we introduced autoscaling at Blizzard for Overwatch, we saw an overall 40% reduction in the VMs used by Overwatch. And with that reduction, we were able to reallocate that capacity to other games and other workloads. Now, another major benefit of autoscaling was that the game teams could now perform blue-green type of deployments more easily. For instance, if you imagine Overwatch is releasing a new map or a new character, they can spin up a new cluster of game servers that has a new content. They can do all the testing against that cluster. And when they're ready to go live, they can switch over the traffic to point to the new cluster, and then they can slowly scale down the existing cluster as the players that are connected are being drained. Now, there's also another benefit to autoscaling, obviously, and that is to be able to handle unpredictable traffic. For instance, if a popular Twitch streamer is playing Overwatch, we might see a spike in Overwatch traffic because people might log in and try to play along. And what happens in that case is that autoscaling is able to scale out and add game servers as needed, and then remove those servers as the traffic dies down. And this is able to happen without any human intervention. And finally, autoscaling also has an additional benefit, what I call cloudiness of game servers. Now, traditionally, game servers in our cloud had a very long lifetime. They would be up and running for weeks and months on end. But with autoscaling, the lifetime of VMs actually becomes much shorter as you're constantly scaling up and scaling down. So the VMs would potentially only be around for a few days. And with that reduction of the lifetime of VMs, you see fewer of those long-running bugs that you usually see, like memory leaks or connection leaks. And now Jude will talk about a little bit of the challenges that we had when autoscaling the game servers.
All right, some of the challenges that we faced when autoscaling game servers was traditionally autoscaling removes servers from when the overall load of the server drops. Game servers host long-lived stateful connections for individual game sessions. Terminating a game server abruptly disconnects players from the ongoing game session. Autoscaling servers requires the ability to drain existing connections from servers that are removed. Game servers can last hours, or game sessions can last hours, so that draining may take a long time. And the gist of it is any sort of interruption in a game, whether that even be 1 second, can dramatically impact a player's experience. So it could be the difference in whether or not you secure a kill or capture an objective. So we really need to maintain the state of the server when we are doing any sort of changes to the server infrastructure. So the way we fixed that problem was we implemented lifecycle hooks in Senlin to drain the nodes before they were deleted, which allowed us to just make sure that there was no players on there when we decided to do something to it. Some more challenges that we faced. Traditional autoscaling relies on the VM metrics such as CPU, memory usage to make scaling decisions. Game servers reserve all of the RAM on a VM, and the CPU utilization can spike depending on physics calculations or whether or not something is happening within the game servers. Those aren't really reliable metrics to use for game servers, or for getting people off of game servers. So we let the game servers calculate their definition of load independently, which allowed us to just expose load to the autoscaling service, and the autoscaling service was able to make scaling decisions based off of that. So autoscaling evolution at Blizzard, we initially implemented it in AWS, and then we investigated autoscaling with Heat, but the Heat's implementations of the Heat implementations API was very different than the one that we already had implemented for AWS. So in the end, we decided to use Senlin for autoscaling. First off, when we implemented Senlin, we implemented lifecycle hooks to support draining the players off of the servers. And then The Senlin API also closely matched AWS, and they also had the REST API for scaling clusters down and up. And we also implemented Gopher Cloud and Terraform extensions to support Senlin clusters. The autoscaling implementation at Blizzard consists of Senlin, Zakar, and then the Blizzard autoscaling service, which is just a custom Go application that is deployed alongside the game cluster, which basically manages or works with the public cloud and the private cloud and runs basically alongside every game cluster. So to go further into the Blizzard autoscaling service, the autoscaling service discovers instances of the cluster and monitors their state, regulates and calculates a rolling average of the load of all the instances in the cluster, requests Senlin to scale up when the average load rises above the scale up threshold, and then scales down when the average load drops below the scale down threshold. It also pulls the Senlin message queue, which is the Zakar queue, for the request to remove an instance. Basically allows us to target an instance, saying, hey, this is the one that we want to remove, so then we can start draining players off of it. And then also we store metrics for the game cluster that is published from the autoscaling service so that we can kind of like have a history of the load average of for that server. So I'll go over what that looks like. This is the less interesting of the two. This is for scaling up. So the components involved are Senlin, Nova, the game cluster, the autoscaling service with the game servers inside of it. The autoscaling service will determine the load of the game servers and then request Senlin to scale up. Senlin will then create a server from Nova, and then Nova creates that VM. Scaling down, which is a little bit more interesting, we have Senlin, Zakar is involved in this one, Nova, the game cluster with the autoscaling service and the game servers. The autoscaling service will determine the load from the game servers and then request Senlin to scale down. Senlin then publishes a lifecycle message for the elected node that needs to be deleted. The autoscaling service will then consume the lifecycle message and then trigger that node to drain. So once that node's completely drained, the autoscaling service will then trigger the lifecycle hook, informing Senlin like we're safe to delete this server, and then Senlin will delete the server within Nova, or request Nova to delete the server, and then Nova will actually delete the VM. So we faced a lot of challenges when we started using Senlin and scaling it up to enterprise scale. There's a major database inefficiency. Cluster list and action list operations were extremely slow when we had hundreds of clusters. Some of those requests would take, hundreds, if not forever, to return. So we updated the DB models, removed unnecessary DB calls, and we reduced some of those calls by 1,000%. That might sound like I'm speaking hyperbole. I'm not. It was 1,000%. So, we also encountered a lot of database locking, which when we started doing a lot of simultaneous scaling requests, we would get a lot of failures from the database. So we added a lot of retry on deadlock logic to the database API in Senlin. Additional challenges that we faced, actions in Senlin were queued up and processed asynchronously. Failure checks happens asynchronously as well. This caused a problem for our autoscaling service. Essentially what was happening was somebody could queue up a lot of scale up or scale down requests, and it would lead to us not understanding the state of our clusters. So there would be multiple scale up or scale down requests, which would all create either VM creates or VM delete actions. And depending on the the cooldown or the conflicting actions or the locks that were being applied, we were unsure what was happening until that request failed. So the way we solved this was we exposed the concept of the locks, the conflicting actions, and the cooldowns to the API so that when a request comes in, we would fail fast from the API. We'd be like, oh, you can't scale up your cluster, you're already scaling down, or you can't scale down because you're already scaling up, or something's happening, so we would understand immediately the state of our cluster. I'm going to hand it back over to Duck. He's going to go over some of the metrics that we were able to collect from our autoscaling service.
Thank you, Jude.
All right, so let me show you some data actually. So what you're looking here at is some data that we collected over a period of 2 days for a single cluster of game servers. And let me start off by looking at the load. So what you're looking at here is the aggregated load for a single cluster as it's going up and down during the period of 2 days. So you can see during certain times of the day, the load is high as expected, and during other periods of the day, the load is dropping, and then it goes up again. And this is a typical cycle for most auto-scaling applications and even our game servers. Then with our auto-scaling service, we define scaling thresholds. So we have a scale up and scale down threshold. So what happens is when the load increases above the scale up threshold of 65%, as you can see here, we will be scaling up and adding additional nodes. And if the load were to drop below the scale down threshold of 40%, like here, we will be removing nodes from the cluster. And you can see that when I enable the number of desired nodes here. So what I'm showing here is the number of nodes that are requested by our auto-scaling service to Senlin. So right here, when the load is spiking and going above the threshold, we start to scale up. And we continue to scale up until we hit a maximum size for the cluster. And when the load goes below the scale down threshold, we start to scale down the number of nodes. And the cycle repeats itself. Now, another interesting thing to look at is also the number of active nodes. So the difference between desired and active nodes is really the number of desired nodes is what our auto-scaling service is requesting to Senlin, and the number of active nodes is what Senlin is reporting. So in the case of scaling up, those two lines actually match up. But during scale down events, there's a small deviation. And what you're seeing here really is the lifecycle hook in action. So when Senlin, or when the auto-scaling service is requesting a scale down event, Senlin will pick a node and will start, trigger the lifecycle hook and start draining the players. And once all the players are drained, it will go ahead and delete that node, and the number of desired and active nodes match again. And as you can see, the time to actually complete the draining varies. It could be about an hour or almost an hour and a half here to very short over here. And that really depends on the number of players connected and so forth. And let me go back to the slide deck. So after running autoscaling in production for almost 6 months, there's a few things that we actually learned. The first thing that we saw was that the keystone trusts used by Senlin are very fragile. So what happens in Senlin is that whenever a user creates a new cluster, Senlin will create a trust, a keystone trust, between its own service account and the Senlin user. And then when you are asking to Senlin to scale up or scale down, it will use that trust to perform actions on behalf of that user. Now, if you happen to remove roles or permissions for that original user account that created a cluster, that trust would become invalidated because trusts, by definition, are immutable. And that would cause a problem because Senlin operations would no longer function. You could no longer scale up or scale down, and your auto-scaling will be basically broken. And we kind of looked at that, and one of the solutions was for us to start using bot accounts. So we create actually these fake bot accounts that are not associated with any actual user, and we use them to create Senlin clusters exclusively. And we had put operational procedures in place so we don't modify roles or permissions associated with that account. Another thing that we learned was that action tables and events tables in Senlin are going unbounded. So what happens in Senlin is whenever a user is requesting scale up or scale down, it will record the action in an action table. And if you imagine, if you're running at a large scale like us, with thousands of nodes and scaling up and scaling down 24/7, that table is growing big really fast. And what we had to do when we looked at that is to actually start purging actions and events that were older than a certain amount of time. And for us, we implemented a cron job to do that. And after the implementation of that, the API response times for certain requests like action lists or cluster lists or even events lists was coming back much faster. And so in summary, I mean, after we introduced autoscaling for Overwatch, we saw an overall 40% reduction in the VM footprint used by Overwatch. And that freed up capacity, we were able to redistribute to other game services and workloads within our private cloud. And if you'd like to learn more about autoscaling, please join us in the Senlin upstream development. We are both very active in IRC, and also provide feedback to the autoscaling SIG, which is basically trying to address all the larger autoscaling use cases and problems. Thank you very much. And I think at this time we have time for some questions. Would you like to go ahead? Use the mic?
So when you're waiting for users to bleed off on a scale down event, you mentioned there was random events that can cause need to spike. If you're waiting that hour to 2 hours, does Senlin have some way to overwrite the call to bleed the users and re-enable that VM for new connections, or does it have to create a new VM and keep bleeding that one so you're kind of doubling your resources needed?
I believe once it's in the draining state, it will finish draining because you already kind of trigger the lifecycle hook.
Yeah.
And autoscaling will continue draining that VM because the players are already, as players are disconnecting, you're already waiting for it to complete. And then if, I guess, it spikes again, you would add new servers.
In Senlin, we also introduced the ability to cancel actions too. So in theory, you could use that to cancel the scaling action, or the lifecycle hook waiting, essentially, and then do whatever you needed to do afterwards. But usually we stayed away from that just because it would lead to weird states. We just continued to drain the people off of there, and if it needed to scale up, we could. It's sort of the paradigm of autoscaling a little bit, though. We scale up, really aggressively, but we scale down very cautiously. So we try not to get ourselves into a situation where we don't have capacity to do something. So that's sort of the way we handle autoscaling.
And really during the integration and testing of the autoscaling rollout, you kind of have to set good thresholds for scaling up and scaling down. You don't want to scale up only when it reaches almost at the peak, and you don't want to scale down too early. So you really have to kind of play with those thresholds and find the right balance.
Awesome, thank you.
By the way, we have a little bit of swag, so if you ask a question, come see Amy right here at any point. She'll give you some swag. There isn't a lot. I could only bring so much in my bag, so it's hard to fly with a bunch of random stuff.
Go ahead.
I'm just curious to know if you have an active game session and you need to drain the users off, do you have to copy the state of that VM to another one so those users can continue playing their game?
No, so the draining actually waits for all those players to finish playing and however long they're on, and then we only delete once those players are off. So those VMs stay around, so we don't want to impact.
Yeah, we don't want to impact or have to copy state at all, so we just wait till they're completely done on that server, and then we'll delete it.
I was just interested in your custom autoscaling service that effectively, as far as there is some logic inside, but it also processes custom metrics, right?
Yeah.
Would it benefit you if there was a ability to process arbitrary metrics sent from user applications, for example, through Monasca or Ceilometer, so that at least the metrics processing and aggregation can happen in the cloud service, not in something you deploy as a sidecar?
For sure. The reason we started kind of with that additional sidecar VM is there wasn't really a good implementation of a custom metric that we could expose. Because what the auto-scaling service does, it basically does HTTP post calls and kind of gets the metrics from each VM and aggregates that. And there isn't really anything around in OpenStack right now that does that. And in addition, we are using that also, the same implementation in AWS. So we needed we needed something that was could use in both clouds.
Yep. Okay, got it. Yep. Thanks.
Hey guys, quick question on your autoscaling. You showed that multiple games could burst into each other's kind of available space. Did you have any kind of maximum so one game could not maximize the entire cluster?
Yeah, we do have tenant limits.
So the regular tenant limits still take effect?
Yes.
Okay.
And there's maximum settings for each cluster. Actually, you can set like the cluster can only scale up to this number or scale down to that number.
Changes of Senlin already merged to upstream?
Yes.
Yes.
So we are running on Stein release, and
Stein.
everything is merged upstream, yes.
Thank you.
Do you guys ever have trouble when scaling down with VMs that never actually finish draining, or is your kind of workflow very definite on that?
I think there's probably like an upper limit of how long a
it'll
VM can
wait.
stay around, maybe like a
I
couple
mean,
days or something.
Yeah, I think it's like that, but I mean that's kind of up to the game server to manage a little bit too, because I mean the game server session is essentially the thing that we're waiting on. It's like somebody connected to that game server playing. So we're just waiting for really them to stop playing, and then they won't get another session back.
Okay, so you have a pretty defined kind of, this is done, it's drained. There's not a lot of stuff that will like hang around and you have to go back and have some other process that goes in and kills that.
Yeah, we usually don't encounter that.
This may be a bad question, but are you considering migrating to containers so that you could move load more dynamically? It sounds like you have to wait for users to exit, but in concept, in a container environment, in a pod, you could be more dynamic with that.
I mean, obviously the future is containers, but a lot of times with game servers or games, it's a lot of legacy software that we have, and they're built, before even containers were around. So they are really reliant on the VM concept.
And would you imagine, I mean, I was in a lightning talk yesterday in the scientific SIG where they were showing like latency comparisons between like Kata containers, VMs, and bare metal. Mm-hmm. Clearly there's some performance hit by moving to Kata. Just wondering if you're in a state of evaluating those kind of parameters since you need high performance.
Actually, I don't have any insight on that, but that was really, I think, something the game teams would do themselves.
Yeah, for sure.
Hi.
Regarding the capacity planning, so when you scale down and you have free capacity, do you have a buffer of free resources? Or if you give them somewhere else, then how do you claim back the resources?
I think what we really see is when people first start using autoscaling, before autoscaling, they would reserve the max number of VMs possible. And that would really be for peak times, but those peak times only happen, maybe 10% of the time, or very rarely. And during 90% of the time, the load is, on average, spread evenly amongst those VMs. So most of the time, we can, give that free capacity and reallocate it, repurpose it for other workloads. But then we also have, obviously, some spare capacity. And when we know there's a release of a new map or a new hero or something like that, and we anticipate more traffic, those peak times, then we have that spare capacity available to kind of potentially scale out much more.
Okay. And when you want to scale up again, is there any situation that you may try to claim from another running application capacity, or it always comes from free capacity?
It comes from free capacity. So the way the game teams usually manage it is they set a lower threshold for the lower max cluster size, and when they know they need to have about to hit a peak time, they kind of scale up, much more. They set the cluster size much higher, and so they can scale up much higher, and that is available in our kind of buffer or spare capacity that's shared amongst all games.
Thanks.
Okay, the question is there any advantage for a player to be on the draining virtual machine instead of being on the fully deployed virtual machine in terms of game latency or the response from the game?
No, they wouldn't see any difference. It would be completely the same experience for the player. I mean, that's something that's super important, is maintaining the same level of quality no matter what we're doing. So we make sure that, no matter what we're doing to the infrastructure in the background, it impacts the player 0%.
How do you ensure that there is the same latency for all the users across every single virtual machine?
I don't know if I can talk about that, actually.
Anyway, thank you.
Hi, my question is for the load. You are talking about CPU and memory, but what about disk performance? You didn't run any problem with IOPS or something like that in the game servers?
I mean, the point that I was trying to get to more so was that we don't want to rely on those metrics like CPU or memory utilization. We more want to rely on a custom metric that the game server creates. So that could be an aggregation of CPU, memory, disk usage, but it's usually not. It's usually some other metrics. But it's less of a what we're using and more of a allowing the game servers to define whatever they want is what they would think of as load. So.
Hi. You were talk about Overwatch, but these also have games like Hearthstone, which is not so dynamic. Do you know if the people running Hearthstone has the same problems? Because Hearthstone look like more HTTP. It's not like so dynamic. So do they have the same problems to scale up or scale down?
We don't. The only game that we have it deployed for right now is Overwatch. So I mean, it's something that we're always looking into to try and onboard more games. But right now, the only game that's taking advantage of autoscaling is Overwatch.
Thank you. Hi. You mentioned you're using AWS too, so are you running some kind of hybrid cloud thing and do spillover to AWS, or how does it work?
So yeah, we do use AWS, or we have used AWS in the past, but spillover is nothing like automatic. I mean, it's something like if we have clusters in our private cloud, sometimes we set up additional clusters in AWS if we need it. Okay. But it's not like automatic.
And how do you calculate those load metrics you talked about with the autoscaling service?
It's exposed by the game server, and it usually boils down to connected players a lot of the time. So I mean, it's just like how many people are still around that are connected to this thing determines the load, because the VMs will use all of the capacity that they're given to servicing that game. So whether that be RAM or CPU utilization.
But it's really up to the game itself, because for the gaming service, we make a call and we ask okay, what's the load for this VM? And they just report a percentage back to us. And then we take that percentage and aggregate it for that cluster and make scaling decisions based on that. So it's just a number.
Okay. Are your developers using self-service for this, or are you helping them on most of it to implement all this stuff with the clusters and so on? And how does it look like for testing and so?
I'm not sure.
I mean, we do help them directly as being the primary developers for the autoscaling service. So we will interface with their, infrastructure team to do whatever they need to do. So we do help them hand in hand to understand exactly what we're trying to do and understand what they're trying to do.
Okay, so the developers have so every game has its own infrastructure team that operates with your stuff? Or?
Yeah, I mean, they are the users of the cloud, so they have abilities to create VMs and use Senlin APIs and so forth. So they are our customers, our users.
Okay, thank you.
How's it going? So I'm assuming the initial reason for you guys doing autoscaling was to lower power consumption and everything like that. Is that correct, or is there some other reason why you wanted to go down the autoscaling path to begin with?
I think it started out because we were using AWS, obviously, and we wanted to do autoscaling to reduce the cost. But then we saw the benefits of autoscaling, that it could potentially free up capacity in our own private cloud, more so than cost reduction in cost of energy or something like that.
So just flexibility for other games then?
Exactly.
So does that impact any capacity planning, overall for actual physical hardware as well, down the road? So you're all these different games, now you've got all these different competing bits competing for physical hardware.
I'm not sure actually how that affects capacity planning because we are still at the early stages, after rolling out autoscaling.
Yeah, we haven't really answered the capacity plan yet.
All right, thanks.
So I'm curious, do you guys have a static number of game clusters that you have in various regions? Is that also dynamic, or have you guys not run into that problem yet?
Static. I mean, we don't actually define how the game teams are using it, so they create their own clusters, and
Yeah, they can create as many clusters as they want, so it's not a static number per se. They just deploy as many as they need and then put them into autoscaling.
One more question. Do you guys have a minimum and maximum number that you guys have in each cluster that you can manage?
Yeah.
Yes.
Cool. Thank you.
And another question that came to my mind. Do you use any holistic scheduling from Senlin? I mean, the question is, how do you choose victims for scale down?
So there's a deletion policy that you can, or scaling policy, I believe, or deletion policy for Senlin. And there's different ways of selecting the victims. I think it's first in, first out, or random. So there's different methods for that you can apply.
Okay. So, I mean, but you consciously choose which other algorithm you want to use for victim choosing. Yep.
Yeah.
Okay, thanks.
Do you deal with concurrent scaling policies, and how do you deal with backfilling of scale downs, and if something else needs to scale up into a region that's been overtaken by some other workload? You talked about using scale down to allow the running of other workloads, but if you need that space again to scale back up, what do you do about that?
Usually we have enough free capacity where that's not a problem. We haven't really gotten into a situation where that's happened yet. So we usually, the way the tenants are divided up, it will allow it to never really encounter that situation where there's no capacity to scale up to. So.
Yeah, you said you're only dealing with one game currently, but if you onboard additional games, that
will be a question that we need to answer for sure. I think that's all the time we have. Thank you guys so much for coming to our talk.
Thank you.